Alright, today we're going to talk about segment lengths within circles. So a lot of our diagrams are going to look the same as what you've been looking at, where you have a circle and two chords, or a circle with two secants, and a circle with a secant and a tangent. So a lot of those same vocabulary words are showing up in today's lesson. But instead of trying to find missing angles that are created within these diagrams, we're going to be trying to find missing links. So if we take a look at type 1, when you have two chords that are intersecting, the point of intersection divides up your chord into two different parts. So if you're trying to find a missing variable or a missing segment length, you would use the formula A times B. So those are the two parts from one chord, and you set it equal to C times D. So the other two pieces or parts from the second chord. So two chords, the point where they intersect divides up your chords into two parts. A times B from one chord equals C times D from the second chord. So that is type 1 situation that you might see with your segment lengths within a circle. Type 2 is two secants. So with a secant, it goes through the circle, and you have a segment that is outside of the circle. So you're going to take the segment that's outside and multiply that by the whole segment. So to get the whole segment, we're going to have to add the part outside plus the part inside. So I'm going to write that out as A plus B for that segment 1. Equals segment 2, the part outside, times the whole C plus D. So if you'll try to remember, outside times the whole of secant 1 equals outside times the whole of the secant 2. And that's the second situation that you could see. The third type is when you have a secant and a tangent line. So I like to think about type 3 similar to type 2. You're going to take the part that's outside of the tangent times the whole tangent, which is going to be just times itself. So outside times the whole would just be A times A. And another way that we could write that is A squared. So A to the second power. That takes care of your tangent. The secant, set it up the same way we did for type 2. Part outside the circle times the whole secant, which is adding together the B plus C. Alright, so let's take a look at some examples. We're going to do number 1 together. And we first have to ask ourselves, are we looking at type 1, type 2, or type 3? And here in our diagram we have two chords intersecting. So I'm going to use my formula for type 1. If I focus just on one chord at a time, the two parts, 14 times 15. Doesn't matter which chord you start with, but you're going to multiply the two segments together, 14 times 15. Equals, look at the second chord, and I'm going to multiply the number 10 with the variable x. So 14 times 15 equals 210. 10 times x, I'm just going to write that as 10x. To solve for x, we would divide the left and right by 10, and 210 divided by 10 would be 21. So for number 1, it just said to solve for x. So once you figure out what value x equals, you are finished. The next one we're going to look at is number 4. So this is still a type 1 situation where we have two chords that are intersecting. So I'm going to focus on chord PQ and multiply each segment. So 14 times 2x plus 1. And I'm going to put parentheses around the 2x plus 1 just to remind me that I need to multiply 14 times both of those terms or use the distributive property. Equals chord 2 RS. I'm going to put the 18 first and times it by 2x minus 5 and set it up with parentheses so that you remember to distribute the 18. So 14 times 2x would be 28x, and 14 times 1 would be 14. 18 times 2x would be 36x, and 18 times negative 5 would be, what is it? Let's type it in. Nine. So I'm going to subtract 28x to combine like terms. And that would be 8x. Add 90. (104) equals 8x. And then when I divide 104 by 8, it equals 13. But before I box this in, you can tell I was about to get ahead of myself. Number 4 asked for us to find TQ. So T to Q is talking about this distance or this length of your chord. So I need to plug the 13 in for that x. Two times 13 is 26 plus 1, so TQ would equal 27. So notice the difference in examples 1 and 4. They asked us to find an actual distance from T to Q. So once you found the value of x, plug it back in to get your final answer. All right, the next one we're going to do together is number 5. This is a type 2 situation where we have two secants. So we're going to multiply the part outside with the whole secant and set it equal to the part outside of the second secant times the whole. So for number 5, just look at one secant at a time. The part outside is 8 times the whole, so I'm just going to add those two together. The 8 plus the 19 would be the distance of the whole, or the length of the whole, equals the part outside of the second secant times the whole, 9 plus x. So we can take care of 8 plus 19. Which equals 27. And here I can distribute that 9. So in Desmos, I'm going to type in 8 times 27. And I get 216. Subtract 81 from 216. 135. And then divide both sides by 135, and that will give me my value for x. 15. All right, let's flip over and do 11 and 13 together. 11 is a type 3 where we have a tangent with a secant. So I'm going to take care of the tangent first. The part outside times the whole tangent is going to be x times x. And then the secant, the part that's outside, times the whole, which is 27 plus the 21. X times x, we can write that as x squared. And then 27 times 48. And I'm going to multiply 27 times 48. $1,296. And instead of just having x to the first power, my equation is x squared. So this is a quadratic equation where you have to either factor, use the square root method. You can graph this and look to see where your two zeros are. You can do the quadratic formula if you choose. There are a lot of different methods to solving a quadratic equation. And we know it's a quadratic when we see that x squared. But for this one, I'm going to choose to take the square root of 1,296. Which equals 36. We have to remember that it could be positive or negative 36. But because x is talking about the length of a segment, you can't have a length that is negative. So we're only going to keep the positive answer, which would be positive 36. And the last one we're going to do together is 13. So back to a type 1 situation with two chords. So part 1 times part 2, 1 chord, 12 times 10. And then multiply the other two parts together from the second chord. So 12 times 10 is 120. Here we have a binomial times a binomial. So I chose to set those up with parentheses to remind myself that I need to distribute. Or you may think about this as FOIL, x times x. X times my outer, and then my inner. This is going to be 6x and a negative 1x. Those would combine and give me 5x, and then a negative 1 and a positive 6 would be negative 6. So once again, there is my x squared showing up. So this is a quadratic equation. We need to use square root method, quadratic formula, complete the square, graph it, any of those methods that you feel would work best. I'm going to combine like terms so that this quadratic equals 0. And I'm going to graph this in my Desmos. And zoom out a little bit. My two zeros are at 9. So there's one solution for x. And my other possible solution is negative 14. If we take negative 14 and plug it in for either of those x's, I'm going to have a negative length, and you cannot have negative distance. So we're going to keep the positive answer, x equals 9. Alright, so for homework you are to complete all the other examples that we skipped over and put your answers in on the haiku. Thank you.